Hi, my name is Bill. Welcome to Probability and Statistics for Everyone. This is our second installment of Video 4, where the general task is presenting, describing, and summarizing data. Here in Video 4.2, we're going to focus on quartiles, including the median. With the quartiles, we begin the process of reducing or compacting raw data down into descriptive statistics. So let's get started. We'll begin with 10 values, which represent random samples from some system or process. Now notice that these aren't the same values we used in video 4.1. Next, as we learned how to do in the previous video, we'll present the dot plot and the EDF of these values. In order to produce the EDF, the data values needed to be sorted. So let's go ahead and display those. Notice that we've changed x sub I to y sub I, where I equals 1 to 10. The y sub i's are called the order statistics, so that y sub 1 is the smallest value, y sub 2 is the second smallest value, etc. One way to think about statistics, or statistical analysis, is that it's about filtering out as much randomness as possible, or advisable, from the data to reveal the deterministic qualities about the system or process that produced that data. Now, I added the caveat advisable for two reasons. First, when filtering out the randomness, we risk filtering out some of the information that we're wanting to investigate. So we need to be careful about doing that. Second, sometimes there are certain characteristics of the randomness itself that we want to investigate. Either way, if the appropriate amount of randomness isn't filtered out, that randomness can interfere with our ability to investigate the quantities or qualities that we're interested in, which lie underneath that randomness. What that means for us here is that we don't need to retain every bit of information from every value in the original data as we received it. In fact, we want to reduce that data down to certain key features that describe it. We take our first steps in doing that here by extracting or calculating the first, second, and third quartiles. These quartiles are the values that split the data up into quarters. Q1 is the lower quartile of the data. It's the value for which 1/4 of the data is below and 3/4 of the data, or 75%, is above. Q2, also commonly called the median, is the middle quartile of the data. It's the value that splits the data in half, where we have 2/4 of the data below and 2/4 of the data, or 50%, above. Q3 is the upper quartile of the data. It represents the value that splits the data so that 3/4 of the data is below and 25% of the data is above. We're going to find each one of these values for this data set, beginning with the median. We'll initially pursue the median graphically, using the EDF, by drawing a dashed line at the 50% or 0.5 level. What we notice in this plot now is that this line intersects with the EDF in one of its horizontal regions, between the values 4.403 and 5.064. This means that there is not a single unique value in the data that defines the sample median. Our approach, then, will be to take the mean of the two adjacent points near that center. Based on that, we find the median to be 4.73 and indicate that by the vertical dashed line on both plots. If we focus in on the dot plot for a moment, we see that there are 5 dots to the left of the dashed line and 5 dots to the right. Now, any value between 4.403 and 5.064 would have placed this vertical dashed line between them. But the standard best practice is to compute the mean of those two nearby points, effectively centering the vertical dashed line. To the left of the plot, you'll see an algorithmic expression for achieving the same result. We'll next find the lower quartile of the data, also called Q1. As before, we'll begin by drawing a dashed horizontal line on the EDF, this time at the 25% level. What we see here is that the dashed line crosses the EDF at one of its vertical segments, indicating that there is a single unique value that signifies Q1. We can indicate that value as shown on both the EDF on the dot plot and present the value. Similarly, we'll find the upper quartile called Q3. We're going to go ahead and wrap this video up, because in this video I simply wanted to introduce the concept of quartiles to get ready for describing box plots, which I think we've done now. There's a lot more we could do here, of course. We could more thoroughly define the mathematical notation on the left, or look at other example data sets with different numbers of samples in them. But the graphical approach we've used will work for any data set, so we'll defer all that to another video. We'll simply close and anticipate video 4.3, so check back soon.